So now we will see about the linked list implementation of the that is stack implementation using linked list, because you should be aware of both array and linked list. So here we know that it's normally, what is the advantage of your array and linked list. So here there will be dynamic allocation, and you are going to use pointers over here. When you are going for an array, there won't be dynamic allocation. Array will be having a fixed size, so you have to keep on while inserting, you have to make the bring all the elements down if you want to insert in the middle, or while deleting you have to, after deleting you have to move all the elements to the up. So pushing up and down is there in the array. So but linked list, it is very easy. You will free the particular, you will allocate the memory space and free it, that's all. So this is what happening in the linked list field. And here in linked list, as you know that normally in a representation of a linked list itself, you will be having a information field, that is your data field, and your pointer field to the next element. So here the first element will be always null. You know that because see, in linked list you keep on when you insert an element, uh, if there is no other elements, that field will contain null. Next, when another element gets inserted, that address, the previous address will be held in that particular address. This is what actually happens. And towards the last element will be, here the last element will be null in normal linked list. Here it is one way of entry and exit. So the next field of the first element will be always null, and assume that you have an element which will be inserted to the left hand side. So I'll show you the representation. Now you can see here dynamic size, information, and the next pointer hold for the next neighboring element. So this is how you actually process. See here, the first element. This is the first element where there is null. Then this address will be in here. This address will be here. This address will be here. Okay, so this is what will be. So this will be holding this previous address. This will be holding this address. This will be holding this address. Then this is null. So this is what actually here the top pointer where it holds this one's value and that is. So this is the top of the stack, bottom of the stack, push operation, delete, pop operation. So this is that same diagrammatic representation. This is in this horizontal and this is in the row way, like 1, 2, 3, 4. So this is your bottommost element. Then next, but always your top gets incremented one by one. So now see here, you are going to push 6 is being added up. Then your top, that is the top value. Then again, when you are pushing one, top will be incremented and one will be pushed, and see its neighbor, it's holding the address of the sixth one at 6 address. Now similarly push 7, then again push 8. So these are already explained, and now the top value is in the 8 value 8. Now when you want to pop, what happens is pop only one pop. If I'm calling 8 will be that is your 8 will be removed and top will be pointing to 7 and 8 will be removed. Okay, so this is how which happens in the normal linked list. So now another one I want this way. Can you see the screen PDF?
Yes, ma'am.
Yes, okay. So coming over here, I have drawn some diagrams. That's what I took this. Okay. So here in creating linked list, include all the first normally, then header files and everything, then define a node. The node pointer is the node pointer. You're having a top over here. The top you have to point to null. So like this, all you have to do. Now see here, this is the one. Declare the element of the stack. Struct node. Then you have a data. Then you have a pointer. Same as your linked list. So initialization, always your head node will be null. Now coming to this, if you want to return the topmost element, return that is in top element, return the top information. Information means the data, which is the top element will be retrieved. Now empty, if top is equal to null, that means no other If top is, this is the main point which you have. If top is equal to null, stack is empty, else stack is not empty. Now for pushing the element, you see here, check whether the stack is empty. Always I told you, whenever you are going to insert an item, the first condition to be checked is whether the list is available or not. If the list is not available, normally in your linked list you will be giving head as null. Here you are be giving the top as null. Top equal to null. If it is empty, then which node you are inserting, that is the new node, whatever inserting, that next will be null, because that is your first element. So new nodes next is null. If it is not empty, then you have to point out. So that pointing out, I'll show it over here. New node of next is equal. How you are assigning is here. Void push if top is equal to null. So you first allocate. This is allocation. And this is as I told you. If your first element is null, then your tops next will be null, because the element which you are pushing is the first element. So top next is, normally in your previous in linked list all you would have given us head. That head only. Here for stack, always the pointer which is used in practice is top. Okay, so tops next is null and you are inserting the item. In case, now you can see this diagram. Already an element is there. A is there. Already A is there. Now you are going to insert. So this part, this top is equal to null part is only for the element which is not there. In case if you have element in the list, for example, A is there and this is my new node, B is my new node, this is my, assume that this is my new node. So this new node I'm going to insert in above A, that is A is now in the bottom of the stack, B has to be placed above A, that is the meaning. So normally I'll be creating, that is assumed as temp now. This is assumed as temp now, new node. I'm taking it as temp, and you're first creating the memory space for it. Then what I will do is, see already A is there, which is the next pointer is null. Now I'm going to insert B. So what I will do is temp next, that is temps next should be top. This link I have to now create, right? So temps next is top. Okay, temps next, this is holding now this address top. Now you have to insert that information. This all are default values, you know it. Temps information is the data. This line can be in any order, and now you have to, since you have now created the link, temps next is top. Once you have inserted this cannot be placed as temp itself. Instead you have to replace this top name to here. Okay, so you have to assign temp is equal, this top will come over here. Temp is equal to this line, you have to insert. Temp is now assumed to top. Clear now? Clear? So in this, if it is null, you will be having the next as null and the information data you are inserting. In case if it is not null, already you have an element, then you insert an element B, that is the data is B. So this will be assumed as temp. So first create this temps information data, then you create this link temps next is top. After creating this link, now this cannot be as temp itself. It has to be replaced with the name top. So now assume this temp to top. Temp is assigned to top. Okay, this is what insertion happens. Well, that is pushing happens. Now when you come for deleting the stack, are you clear in this, ma? In pushing, if you know linked list well, this will be very easy. Are you clear, students?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, okay. So deleting an element is similarly. See, when you are inserting an element, that condition is called, you have to check a condition, that is overflow condition. That condition is called as overflow. Overflow means whether if the stack is full beyond is up to the limit, you cannot insert any elements into the stack. Similarly, when you are deleting an element, you have to check for the underflow condition. That is deletion not. Underflow means if there are no elements in the list, that is not, it's not possible to delete an element. So if it is empty, then display the stack is empty or deletion is not possible. So here how you are doing is, first you are assigning, see already there are a few elements in the stack. I am going to, see when it is not, when I give pop, I need not give that pop B or pop A, because when I'm pushing, I'll be giving, inserting with the elements, push off some integer value or any character, whatever it is, because the information will be taken. But when I give pop, it is not necessary I have to give pop B or pop A, because pop itself will do only the topmost element will be removed. So just without parameters, pop, that's all. So now see here, the top, that is, this was initially your top value, because I assume that I have two elements in this stack. So what happens, top is now initialized to top 1. I'm initializing top to top 1, and now this is for easy, for our convenience, top is assigned to top 1. Now I am seeing, if top 1 is equal to null, then nothing is possible, leave it out. Else you have to move top 1 to top 1 of next. Top 1 to top 1 of next. That is, my top 1 variable is now moving over here. And this is temporarily there as top. So before removing this, what I'm doing is I'm assigning this top 1 to top 1 of next. Now I can give out the popped value. I can free the top, and after that, this cannot be top 1. I'm reassigning the top 1 to top. This line. Initially this was top 1. Now I am switching over. See, when I'm moving, as you have seen in the linked list insertion in the middle, whenever a pointer is moving to the next pointer, you keep give a name to the previous pointer actually. So here top 1 is assigned, and when it is removed, again you back assign this top 1 to top itself, this line. Okay, and you can decrement the count. That is based upon how you code it. If it is necessary, certain lines you have to add it or delete it, but these links will be similar in all programs. Other lines are up to the question which is being asked. So this is what your pop operation in stack. Now coming to the display is very easy. Same thing, first you have to check whether there are elements to display. If it is empty, then you have to give stack is empty. If it is not empty, then you are going to create a pointer, and you have to move the pointer. You can see here, top is assigned to top. Here normally in linked list will be giving head is assigned to temp. Same thing, here top is assigned to top 1. You can take any name, it is up to your convenience. So top is assigned top 1. If it is null, it will be empty. Otherwise, if it is not null, you keep on moving the variable next to the next to the next, and then you can print it. The printer, here you are printing the particular. If not null, you print it. Then move top 1 to the next. Not null, print it. So this is the way to display your particular stack. Okay, so linked list in stack using linked list will have 3 main operations: pushing, that is inserting; popping, that is deleting; and your displaying. Okay, even searching also you can do the same similar concept of linked list concept only. So there you will be using next. Here you will be, here also you will be using next, but there you will be using as head. Here also you can use head. It is not that you should not use head. Head also can be used, but normally in practice is top, because stack normally a pointer which is in default, which they practice in using is top.